In this video we're going to look at parallel lines and the angles that are formed in parallel lines. And so here we have a pair of parallel lines and we can tell they're parallel because they have these two arrows on them. If a pair of lines doesn't have arrows on them, we can't assume that they're parallel, but because these ones do, then we know that they are. And then we have this red line that goes across them, and any time we've got a line that crosses a pair of parallel lines, we call that line a transversal. Now, it's absolutely possible that there could be several transversals on a pair of parallel lines, but in this one we're just going to look at the one. So we need to be able to recognise different types of angles on this pair of parallel lines. So if we take this angle here and this angle here, you might notice that they look quite similar. And actually, because these lines are parallel, these two angles are exactly the same. And they have a special name. They're called corresponding angles. And they're corresponding angles because they're on the same side of the transversal as each other. So they're both on the right-hand side of the transversal, which means that they're corresponding angles. And they are the same. And as a general rule of thumb, along a single transversal, all of your acute angles are going to be the same and all of your obtuse angles are going to be the same. But you do need to know whether they're corresponding or the second one we're going to look at, which is alternate angles. Okay, so alternate angles, as you might have guessed, are on the opposite side of the transversal. So if we have this angle here, and then its alternate angle is up here. Okay, so it's the same, they're both the obtuse angles, and this angle is on the right hand side of the transversal, and this angle is on the left hand side of the transversal. Now specifically, these ones are external alternate angles, because this one and this one are both on the outside of the parallel lines. But for GCSE, you just need to know that they're alternate angles. Similarly, this angle and this angle are also alternate angles, but they're interior alternate angles. And all of these purple angles, the obtuse angles, are the same. So you need to know those definitions for GCSE, and you also need to know how to apply those, which is what we'll look at in a second. Okay, so on to our next set of examples. We're going to apply the rules we looked at before to work out missing angles. Now with these, it is really important that we also explain why these angles are the same. In an exam, you won't get the mark if you just write down that they are the same, and as general mathematicians, it's good practice to write down our reasoning behind the steps that we're taking. So here we've got 70 and x. Now they're on the same transversal across parallel lines and they're both acute, so they're going to be the same, but it is really important that we recognise why they're the same. So at home, if you can remember, are these corresponding or are these alternate angles? Correct, they're corresponding angles because they're on the same side of the transversal. So corresponding angles are the same or equal. So we know that x is equal to 70. Excellent. Now let's move on to this one. So again, we've got two angles that are along the same transversal. They're both obtuse, so we know they're going to be the same. So are these corresponding angles or are these alternate angles? Exactly, these ones are alternate angles because they're on opposite sides of the transversal to each other. So alternate angles are the same or equal. So y is equal to 120 in this case. Okay, on to our third one. So this one's slightly trickier because we have two transversals. So let's look at y first of all up here. So they're on the same transversal and they're both obtuse, so these two are the same. Note that this one isn't the same as this one. Even though they're both obtuse angles, they're not on the same transversal, so they may well, and in this case they are different. But we know that y and 120 are the same. Can we remember, are they corresponding angles or alternate angles? Good, they're corresponding angles because they're on the same side of the transversal. So corresponding angles are equal. So I know that y is equal to 120 degrees. Excellent. Okay. Now let's have a look at this one. So here we've got an obtuse angle and an acute angle that are on the same transversal. So they're clearly not the same. But what we can do is we can work out what this angle here is. Okay. And the red angle is the same as this 150 degrees, again, because it's a corresponding angle. So we've got corresponding are the same. Now it might make sense to give this a letter so we can talk about it. I'm going to call it A. So A is equal to 150. And now I know that X and A are on a straight line. So on a straight line, add to 180. So I'm going to do 180. I'm going to subtract my 150. And that's going to give me a final answer of 30. So X is equal to 30 degrees there. Okay. Now there is another rule we could have used here to make this slightly easier and a little bit of a shortcut. So let's have a look at that now. So the other way we could have looked at these, and up to now we've only talked about angles that are the same, but the other way we could have looked at them is if you have a look at these parallel lines, these are both on the inside and they're both below the transversal. So they have a special name. They're called co-interior. So co-interior angles. And one of the rules we can say, for exactly the same reason as we've just shown, if this is the same as this and this have to add up to 180, co-interior angles have to add up to 180. So we could have reduced our working slightly by saying co-interior angles add to 180, and then jumping straight into 180, take away 150, gives me 30 for our value of X. So both method is absolutely fine to find X, as long as you're using the correct terminology and can explain what you're doing at each point. Okay, so on to our second example. So I'm going to work through this one. While I'm working through this one, you work through this one. So once I've done a step of working, pause the video and see if you can get to the same point on this one. And then by the time I finish this one, we should have an answer for this one. Okay, so here we've got this X all the way over here. Okay, and we've got two transversals and our pair of parallel lines here. So it's not immediately obvious how we're going to get to X. So it might be worth just forgetting about where the X is for now and thinking about what angles we can find. It might be worth just bearing in the back of our mind that we want to aim for this X, so we want to try and get closer to X as we go, but just for now we sort of want to think about what we can work out. So the first thing we can work out is this angle here. Now I'm going to call this angle A. It's useful to name these angles while we're talking about them, so I'm going to call that one A. Now A and 40 form a pair of angles and have a name. Can I remember what type of angles they form? Exactly, they're alternate angles because they're on opposite sides of our transversal. So alternate angles, alternate are equal. So I know that A is equal to 40 degrees. Okay. So I might be thinking of a strategy now, because we've got this triangle here, and suddenly we know one of the angles in that triangle. So if I can work out what this angle is, then I will be able to work out what this angle is, which is then going to get me closer and closer to this x that we're after. So to work out what this is, we're working along this blue transversal, so let's look at this 110 degrees. So I need to find an angle that I can work out using this 110 degrees. And the one that I think makes most sense is this one. Now how do I work out what that value is? Good, it's 110 degrees because these are corresponding angles. They're both on the same side of the transversal. So corresponding are equal. So again, it might make sense just to label that B. So I know that B is equal to 110 degrees. Okay, so now I can work out what this angle is here. Let's label that C. So I can try and work out C by looking at these two angles. Well, I know these two angles are on around the same point on a straight line, so they must add up to, can I remember? Exactly 180 degrees. So angles on a straight line add to 180. So I know that if I do 180 and I subtract my 110, that's going to give me what this value of C is equal to 70, and that's what C is. So this angle here is 70 degrees. Okay, we're nearly there. Now we just need to work out what this angle is here. Okay, let's call that D. We've not used red for a little while. Okay, so now we have this triangle, and we know that angles in a triangle add to 180 again. So we're going to add this 40 and 70 to work out what they add up to. So 40 plus 70 is equal to 110. And then we're going to do 180 minus the 110, and that gives me 70 degrees for D as well. D was red, wasn't it? 70 degrees. Okay. And then our last step to find X is that X and D are on a straight line. So let's just bullet point our steps here. So angles, straight line, add to 180. Then to work out what X is, I do 180, I subtract the 70, and that gives me an answer of 110, which is our value of X. So X is equal to 110 degrees. So a fair few steps there, 5 steps altogether. And if you want to follow, or if you followed along at home, now's a good time to pause the video because I'm just about to go through this answer. Okay, so nice and quickly then, let's go through this. So we've got all corresponding angles there. So A is 130 corresponding. I'm just going to do the cliff notes here. I'm not going to go through the whole thing in as much detail. So because that's 130, and this angle here, B, is 180 minus 130. So B is 180 minus 130, which is 50, and that's because angles on a straight line. SL equal 180. Okay, so now let's have a look at this angle here. Well, I've got 60 here, which means I can jump straight to C being 60 over there. So this angle here was 50, and I know that C is 60 because they're alternate angles. So C equals 60, and because they're alternate. And they are the same. And so now let's work out A, B, C, D here. Okay. So angles in a triangle add up to 180. So triangle add to 180. So I do 50 plus 60 is 110. And then I do 180 minus 110 is going to give me 70 degrees for D. And then I think we're probably going to get the same answers over here because this one was 72. So angles on a straight line, our final step, we do 180 take away 70 is equal to 110 degrees for x. So if you got that x is 110 and you've got all these reasons written down, then well done.